This is Mr. Precella, and we're continuing working on the review sheet in my face-to-face trigonometry class. And we're graphing the trig functions right now. Let's just review real briefly the general shapes for these. What should you have memorized about the shapes of these trig functions? Well, for sine and cosine, sine has this basic shape. This is y equals sine x, and y equals sine x has a period of 2 pi. It takes 2 pi units on the x-axis for it to make one complete loop around. Now cosine looks like this. I'll draw it. Well, 1, 2, 3, 4. In class we talk about plotting 5 key points. 1, 2, 3, 4, 5. And the same thing here on sine. If you're graphing secant or cosecant, you've got to first graph that sine or cosine. Now for, okay, so this is cosine x. Now for tangent and cotangent, well, one of these has asymptotes at negative pi over 2 and pi over 2. The other one has asymptotes at 0 and pi. 0 and pi, let's say. And one of them from negative pi over 2 to pi over 2. This is where the asymptotes are. And 0 to pi. Well, to remember which one has asymptotes at negative pi over 2 and which one has asymptotes at 0 and pi, I think to myself, okay, which one has the O or the 0 when you look at it? This one over here is going to be cotangent. Cotangent x has asymptotes at 0 and pi, no O there. By default, then tangent x has asymptotes at negative pi over 2 and pi over 2. And to get these shapes correct, one of them goes up when you look from left to right, one of them goes down. The letter immediately after T is a U, so up. This graph goes up when you look from left to right. For cotangent, the letter right after C is D for down. So this one goes down when you look from left to right. Okay. So let's start looking. There's some problem number 11 says, okay, match these graphs. This is sort of the answers that you're going to be choosing are these, the A, B, C, D down here. So you're doing a little matching. Number 1, y equals sine x. You look at this and decide which one of these is sine x. Well, sine x has period 0 to 2 pi, and it's the one that starts down on the x-axis. So graph C is sine x. You'll notice we graphed it right here. Now, if this is sine x, negative sine x would have this flipped around the x-axis. So which one of these looks like that? The graph flipped or rotated, reflected across the x-axis. That would be this one here. Okay, now which one's cosine x? Well, oops, this is negative sine x. At this point, you can probably choose an answer, but I'm going to go ahead and do it all. Cosine x starts up at 1. See, here's how we drew cosine x a little while ago. And goes down. So a is cosine x, which by default, for negative cosine x, if you flip this thing across the x-axis, there's negative cosine x, there's cosine x. So down here, when you look at the answers, we're looking for 1c, 2b, 3a, 4d. That's this one. This is the answer. What do you write in the blank? This c right there. So part of this review sheet is to get you accustomed to all of this. And so these are some nice little matching graphs. And let's see on this one, wow, as soon as you knew 1 was C, you had the answer. Okay. Let's see, is there another graphing line? What's next? Yes. Okay. So the nice thing about these graphing is it lets you choose which ones you should be, or which ones you want to graph to get the answers. You should not, or you should be able to do these without using a calculator. On this test, there's no graphing calculators allowed. Okay. So let's see. Like for problem 2, you have cosine x being multiplied by, okay, we're on problem 12, but for equation 2, y equals 3 cosine x, or for function 2. How does that one differ from this one? Here the amplitude is 3. Number of the trig functions being multiplied by. So we're looking for this shape, but bouncing between 3 and negative 3. Okay, not just 1 and negative 1. It should be bouncing, have that cosine shape, but it's bouncing between 3 and negative 3. So problem 2 is D. There's 3 cosine x. Ooh, that orange isn't showing very well, is it? For 3 sine x, it's the sine curve, but bouncing between 3 and negative 3. So this is the 3 sine x. So that's C. Now for sine x, y equals 3 sine x. Let's do a little bit of writing right down here. For y equals, not 3 sine x, sine 3x. If we took our angle and set it between 0 and 2 pi, for it to make one cycle, it should be going between 0 and 2 pi over 3. So we want this shape going from 0, not 0 to 2 pi, but 0 to 2 pi over 3. So which one of these has this shape going from 0 to 2 pi over 3? I'm thinking it's this one. Look at this. It makes one cycle. See, right here is pi. So 0 to 2 pi over 3. Making one cycle. So this is B. And then the same thing here for cosine 3x. You set the 3x between 0 and 2 pi. You'd want it to be making that cosine curve from 0 to 2 pi over 3. Cosine is the one that starts up here. So there's pi. So is this going one cycle from 0 to 2 pi over 3 on the x-axis? You bet. So A. Well, as soon as you knew 1 was B, you have it. So D. Okay. 1 is B, 2 is D, 3 is C, 4 is A. How are we doing on time? Here's another one. Well, this one's very similar to the one we just finished doing, except instead of it bouncing between 1 and -1 or 3 and -3, like this one and that one. These are the two that have amplitude 1/3. So they're going to be bouncing between 1/3 and -1/3. So that wouldn't, these two look like they're bouncing between -1 and 1. These are the ones that are bouncing between 1/3 and -1/3. So let's see, this one here, looking at 0 to 2 pi, you'll notice it's starting down here at the origin. So is that sine or cosine? That's sine. So C is 1/3 sine x, and D is the 1/3 cosine x. So let's see, just out of curiosity, is that enough? If 2 is D and 3 is C, 2D, 3C, 2D, 3C. Oh, so that's not enough. We can't decide. It's either this one or this one. So let's look at these others. The y equals sine 1/3 x. Well, for some reason, they're not showing the whole curve, but that's good enough. If we just think of the graph of y equals sine 1/3 x. If you set the 1/3 x between 0 and 2 pi, you can multiply through by 3, and that would get you 0 to 6 pi. So sine x, it's going, well heck, why am I drawing that out? So for y equals 1/3 sine x, it's this pattern, except instead of going 0 to 2 pi, it's 0 to 6 pi. So which one of those looks like it's passing through the origin just like this? Well, it's going to be this one here. Okay? If we continue it on, 6 pi, you got to go 6 pi units for it to make the whole curve. Something like that. So sine 1/3 x is at B. Cosine 1/3 x. Cosine is the thing that starts up at 1 and it's bouncing between 1 and -1. But it would go 0 to 6 pi for a whole shape. So right here in pink, here's a rough sketch of y equal cosine 1/3 x. So that would be this one here. Ooh, notice these graphs are cyclic, so they continue on and on. So this one's only showing from -2 pi to 2 pi. It didn't show one complete cycle. So that was A. So let's see, which one is 1B, 2D, 3C, 4A? That one. And that C there is our answer. Okay. Number 14. Okay, this one has tangent and cotangent along with secant and cosecant. Hopefully you can spot that these are the secant cosecant ones and these are the two tangent cotangent. Well, let's see. This one looks like it has asymptotes at 0 and pi. That right there is enough to know it's cotangent, and it goes down when you look from left to right. So 1 is A. This other one that looks like tangent or cotangent has asymptotes at negative pi over 2 and pi over 2, and it's going up, so that is C. Now, to decide which of these is secant x and which one of them is tangent x, let's see. Which, if we had to, would you draw in sine or cosine here? Well, if you look at these key points here, see, this one is cosine, so B is secant, and this would be sine. Okay. So this curve here is cosecant. So let's see, 1A, 2C, 3B, 4D. I'm thinking that is, this B here is the answer. Sometimes students don't understand these multiple choice matching here. And I've seen students do no work or nothing, but they just circle one of these. But these aren't the answers. This is the answer. This A, this B, this C, or this D. And our answer is this B right here. So when I put B in the blank, it's this B I'm talking about, not that B. This B is the graph of secant x. Okay. Oh wow, some more of these. Okay, you've just got to know these basic shapes of these trig functions. No way around that. Let's see. Well, tangent and cotangent. Cotangent goes down, has asymptotes at 0 and pi. So down with asymptotes at 0 and pi. So this first one, A here, is cotangent. This one has asymptotes at negative pi over 2 and pi over 2. So that means it's a tangent curve. But wait a minute, this one's going down. For y equals tangent x, it should be going up. Since this one's going down, that's negative tangent x. The actual tangent x here's negative pi over 2 and pi over 2, and it's going up. So this one here is tangent x. B here is negative tangent x. Notice it still has the asymptotes. All that's changed is the graph has been reflected across the x-axis or flipped across the x-axis, however you want to say it. Right here is y equals cotangent x. Oh wait, so here's cotangent x. If we keep those asymptotes but flip it across the x-axis, we get this one here. So D is negative cotangent x. Again, I'm doing all of these. You could usually get by with just doing a few of them. Okay, so which one is 1C? Oh, this is the only one that says 1C. Tangent x is this one here. So knowing that, you should be able to do it. 2A, 3B, 4D. So the answer here is, oops, I wrote A. Excuse me, I wrote a C. It's supposed to be A. This one right there. Let's see. Okay, one more of these multiple choice graphing problems to do. Dealing with secant and cosecant, and then negative secant and negative cosecant. Well, the secant and cosecant curves you get by sketching in the asymptotes, and here's sine x. Sketch in the asymptotes and draw the little reciprocal figures. Sketch in the asymptote, drawing the reciprocal. Ooh. Ooh, so I'm going to see which one has this shape right there. Asymptotes at 0 and pi, and the little U-shaped figure going up. Which one has asymptotes at 0 and pi? There. So it looks like this very first one is secant x. You can sketch in. Oh wait, I said secant x. That's not secant x. That's cosecant x. I'm sorry. The reciprocal of sine is cosecant. So let me go ahead and sketch this in. Here's the sine curve. Okay. If you went straight through and let's see, like this one here, well, I'm sketching in the sine curve. So this is y equals sine x. Now on this one, you can't sketch in a sine curve and you can't sketch in a cosine curve. This one, you can imagine, is negative cosine x. Cosine normally starts up here, but it's being flipped. So this would be a negative secant x. Ooh, can y'all see that? I'm using that color that doesn't show right very well. This one right here, you're just sketching cosine x. So this one means this is secant x. And this one, well, let's see. What can we sketch in? Well, we can't sketch in sine x. We can't sketch in cosine x. What about negative sine x? There. Y equals negative sine x, so that would be negative cosecant x. So let's see, which one of these was secant C? Cosecant was A. Negative secant x is B. Negative cosecant x is D. So we're looking at 1C, 2A, 3B, 4D. That's this one. Notice, as soon as you know that secant x was this one here, as soon as you knew 1C, you have it done. But I like to go ahead and do more than that. That way, so it's this C that I underlined, that's the answer. Okay. Well, let's take a break and I'll continue with this, with some more of this review sheet in a little bit. Thank you.